So it's preparing. We should be going live shortly. All right, welcome everybody. Welcome to the August Desert Skies Virtual Star Party. So this is one that we do quarterly. And so this is our current one for August. I'm Jim Knoll with the Tucson Amateur Astronomy Association. And with me tonight is Bernie Stinger. He's actually up in Minnesota, one of our TAAA members. And then here in Tucson is Jim O'Connor, Rick Paul, and David Levy. So we're all here in Tucson. Unfortunately, at least here in Tucson, we have clouds. Bernie's got a little bit of clear sky up in Minnesota, so we are going to be able to show you some live views of Jupiter and Saturn. But since we are clouded out here in Tucson, what we're going to do is we are going to show images of objects that we have taken in the past for past events that you would have been able to see live through the telescope. So they will be the ones that we were planning on showing you live. So we'll show those tonight and talk to those a little bit. And then towards the end, we've got a treat. We did a video, Jim O'Connor did a video for the Grand Canyon Star Party a couple months ago on star lore. And it's kind of a neat little video. It's only about 15, 16 minutes long. So we're going to show that at the tail end and let you listen to that. So that's the plan for tonight. So hang in there with us. Please feel free to ask questions on chat. We'll be watching the Facebook chat and we'll try to answer them when we see them. And if you have something you want us to talk about that you think is in the night sky tonight, we'd be more than happy to see if we can find an image of it or at least bring it up and talk to it. So with that in mind, Bernie, I'm going to switch it over to you and you can start with some live views of Jupiter.
Thank you, Jim. Yes, I've got clear skies up here in Minnesota, fortunately. And with that, I want to show you what I've got aimed at here. So I'm going to switch over to my camera and we'll take a look. So what you're seeing right now is a live image of the planet Jupiter. Jupiter in Minnesota here is closer to the horizon, so it doesn't come in quite as well as in the Tucson area, but not too badly. So if I enlarge Jupiter up, you'll start to see that on the planet itself, there are bands. And those bands are actual cloud bands on the surface of Jupiter. There are several cloud bands visible tonight. And the most obvious one here, I believe, is called the South Equatorial Belt. And the one below it is the North Equatorial Belt. Now, why is it north and south backwards? Because we're using a refractor, and the refractor is possibly flipping the image, or maybe my camera's flipping the image. I'm not sure which one. But those are the two equatorial cloud belts that go around Jupiter. And every now and then you can kind of make out another belt right about here that is a little closer to the poles. On this side, not so much, but down here, definitely you can see some polar action. And also, right in this area, kind of comes and goes, but you notice some, looks like a little bluish or greenish tinted objects that are kind of flirting in and out of the vision. And those are festoons of clouds that are paralleling and next to those equatorial belts. Now, you'll notice that the quality of the image kind of comes and goes. In other words, there are times when it's clear and there's times when it's more foggy. And those are what's called moments of seeing. That's when the atmosphere kind of holds steady a little bit and allows a better image to squeak through, because all of the distortion that you're seeing to the image is caused by atmospheric movement, air movement in different bands of the atmosphere. And that's causing the image to jump around a lot. Now, if I zoom back, and then increase the exposure, off to the side, you'll notice a couple of bright spots. And you may have noticed, let me zoom back again. You may have noticed that those bands, if you look closely, those bands are going upper right, lower left. Those bright spots are in the same plane as those bands of clouds on the planet. And those are two of the moons of Jupiter. In specific, this is Ganymede, and this is the moon Callisto. These are huge, icy, giant moons. In fact, Ganymede is, I believe, the largest moon in the solar system. And it's much, much larger than our moon. In fact, I believe it's even larger than the planet Mercury, if I'm not mistaken. And someone can correct me on that if I'm wrong. Now, why are they all on the same plane? For the same reason that all of the planets go around the sun in the same plane, because the moons of Jupiter built up from debris that was orbiting around Jupiter as Jupiter formed. So the spin of Jupiter and the moons of Jupiter are all in the same plane. So I'm going to go back down and look again. At the bands. Now, there are actually 4 visible moons of Jupiter, and we only saw 2 of them right now. So where are the other 2? Well, the other 2 are actually behind Jupiter right now. they're back there. So we can't see them right now. However, within the next hour, we hope that one or possibly both of them, but at least one of them will come around, will swing around, and we'll be able to see it again. And I'm not sure if that was Io or Europa. There's two moons hiding back behind Io and Europa. Io moves faster than Europa does because it's closer to Jupiter. So there's a good chance that it will be Io that will show itself first. So we'll keep an eye on that and get back to it for you if we see it pop up again. Now, this image, if recorded, can be fed into software, and that software can actually go through the images, the video, and pull out all of the best individual images and leave you, I don't know, can you see that? Can you make that out? My picture of Jupiter?
Yep.
Software can improve on the actual image that we're seeing so that you can make out the planets much more clearly. And now here with this image, which I processed with previous video that I had recorded, you can clearly see the two equatorial bands, some of those little festoons of light blue that we saw, and some of the other equatorial bands that we also saw. Now this one, I think we were able to see also previously. So there you go for Jupiter. And I'm going to.
All right, thanks, Bernie. That was
my share
that's good.
Back to you, Jim.
All right, that was good, and it was good to be able to get some live viewing in there. Bernie, talked a little bit about the moons. If you look at when you were looking at the ball of Jupiter, you can put 1,300 Ursa in that ball. So Jupiter is huge. It makes up the majority. It's over twice the amount of matter of all the other planets in the solar system. So the sun makes up 99.9% of all the matter in the solar system, but what's left over, Jupiter has over twice that of everything else in the solar system. So it's big, and it's really great. Both Jupiter and Saturn are really, really cool to look at in telescopes. If you ever get a chance to see them visually in a telescope, by all means, don't pass it up. All right, Bernie, you can go on over to Saturn. And anybody else have any comments on Jupiter before we move on? All right. Yeah, go ahead, David. Yeah, we're not hearing you, David.
I think your mic's turned off, David.
Still not hearing you. No, still not hearing you. Okay, well, I think you're saying we'll come back to you if you want to try jumping in a little bit later. That's fine. Rick, I'm gonna share the screen, and you can talk about the Cave Nebula.
So everyone, this object is known as the Cave Nebula. The reason it's called the Cave Nebula is that dark region in the center is caused by dust. It's actually dust between us and the nebula that's causing that. This is an area of hydrogen alpha gas that's being excited by the stars that are in this nebula and behind it. They're lighting up the gas that's in it. This object is about 2,700 light years away from us and about 70 light years across. it's not visible, not very visible with your naked eye or even through a normal telescope. These objects like this can be very dim, but we can see these objects with cameras and using special, very narrow band filters that help isolate the light spectrum that we're looking for in these objects. Anybody else got anything to add?
Can you hear me now a little better?
Yes.
Okay, thank you. I had to mess around a little bit to get the microphone to work, short of throwing the computer out the window, but here I am. I wanted to thank Kyler Diggs on Channel 9, who gave, I don't know if you're aware of this, but he gave a 1-minute publicity for tonight's star party. And he just went on and on about the TAAA and the efforts that we have gone to do events like tonight's. One of the things we're going to see a little later is Saturn. And my quotation tonight is going to be a deciphered anagram by Christian Huygens, who wrote these words as an anagram in 1656. When they were unscrambled, they came out with this Latin phrase, which is the first Latin words I've ever read. Annulo cingitur tenui plano, nusquam coherent, ad eclipticam inclinato. Translated, it reads, it is surrounded by a thin, flat ring, nowhere touching, inclined to the ecliptic. I think one of the most beautiful things in the entire universe to see is Saturn's ring. And I hope all of you get a chance. You will tonight, at least over Zoom, over our online program. But I hope you all get to actually look through a telescope at Saturn's magnificent ring. And now back to you. Thank you.
Good. Well put, David. That's absolutely true. And yeah, Saturn never disappoints in the telescope, and it'll look pretty good in the refractor that Bernie's on. But the cameras actually don't do the planets as much justice without a lot of tweaking. They're a lot better to see visually, especially Jupiter and Saturn. So I think Bernie is still in the process of moving to Saturn. So Rick, why don't we go ahead and show your next one, which would be the Crescent Nebula.
Okay, the Crescent Nebula. This one's really neat. It's very unlike some of the other objects you'll see show images of tonight. This bubble you're seeing is a shock wave from a very fast stellar wind coming off of a star that's ejecting the equivalent of our sun's mass every 10,000 years. So this star is just throwing off all this material. And then there's another star in the vicinity that's an older red giant that it's got a slower moving wind. And those two winds are colliding, and that's what's causing this bubble to form. So it's really kind of a different nebula to look at. Now, what you'll also notice in this image, you see lots of stars in the background, but you'll also see other rust-colored splotches here and there. This nebula is backgrounded by another larger structure of nebulosity around it. This is located in the constellation Cygnus, and it's the size of this structure is very large. It's about 25 light years across from top to bottom. So a very, very interesting object to see when you know the physics about what's going on here. Anybody got anything to add to this one?
It's a beautiful picture, really, Rick. That's a gorgeous image.
Thank you. Yeah, I was really happy to get this one. This is another narrow band image. This was processed taken with a black and white camera with different filters, very much the same way as the Hubble Space Telescope captures its images. And then those different black and white images were combined to produce this color image.
Yeah, that is a gorgeous one. I was replying on the Facebook chat, so I may have missed this, but I think the distance across the nebula is about 25 light years, is what I had down. Does that sound about right, Rick?
Yes. Yeah.
And let's see, it was created when a shock wave collided with the shell. It was blown off about 400,000 years ago when the star was going, it's a Wolf-Rayet star, when it was going
Yes.
through its dying phases. So it's similar to what's going to happen to the sun, but this is a much brighter, much more intense star than our sun. Bernie, are you ready for Saturn?
Just about.
Okay. Rick, you want to go ahead and do one more?
Yeah.
Let's see, let me go up one. Or actually, I guess this was probably the next one.
Yeah.
Yeah, we can go ahead and do this one.
Okay. I love looking at this structure, this wispiness that just looks like, a thin cloud in our own sky. This is known as the eastern side of the Veil Nebula. There's two sides to this. Believe it or not, my telescope is too powerful to be able to see both sides at the same time. This structure is so massive. Even in our own sky, it's huge. It's much larger than a full moon. This is the result of a supernova. That supernova happened about 5,000 years ago. This object was discovered by William Herschel, a famous name in astronomy, in 1784. This object is very faint, but it can be seen by the naked eye if you're in very, very, very dark skies. It is visible. The other half of this, which I don't have pictured, is a more complex side even, and it has the fun name of the witch's broom. So if you were to go look up on the internet, look up the witch's broom, you might see an image of the other half of this, and they kind of make a circle when they're all connected together. But again, this is gas that's been blown off by a star in its dying phases.
Okay. Well, that was good. Yeah, I love, I mean, that's another gorgeous, gorgeous image, Rick.
Yes, again, this is a false color, but even when I got the first image in black and white, I was just blown away by the structure you're able to see in this. It's just amazing. A frame filling image like this. And this isn't cropped. This is how big this object looks on my camera sensor. It's just huge.
Very good. Anybody else on the Crescent or the Veil? All right.
Is absolutely right. That is a beautiful thing to look at through a telescope on a dark night.
Yeah, you probably can't see quite as much of the colors, but it's still, it's so huge that, it just expands from all the way across the sensor. All right, Bernie, over to you.
Thank you, Jim. All right, we've got everything realigned here. Swung the scope over and got the dome moved. So there we go.
And Bernie, while you're before you start talking Saturn, we did have a question on Facebook about what's the brand, the refractor. I told him it was an 8-inch refractor, but do you know who makes it?
This is a TMB. It's an 8-inch TMB refractor. It's a apochromat, so it's a triplet lens. It's extremely expensive. I don't even want to think about how much it costs. and it's on an Astrophysics Mount, and the mount is on a pneumatic lift, so I can lower and raise it to look at objects further on the horizon. Maybe when we get a chance a little later on, towards the end, I can just tip the camera up here and show you what it looks like.
All right, yeah, and another question we had was when you are star stacking, how many images and how many seconds are you normally taking to get such clear and vibrant shots? That was from Wayne.
Yeah, I can answer that. It does, the exposure time varies by the object, but typically most of my exposures are in the 1 minute to 4 minute range for each image. And then I try to stack as many as I can. The more images you stack, obviously this is someone that knows a little bit about stacking asking the question. The more images you stack, the more you increase your signal to noise ratio. So you get less noise in the image and more, you can separate the image from the background a little bit more. So typically I try to get at least 30 images to stack. At 4 minutes, if I'm doing 4 minutes an image, you can do the math. 30 would take quite a while, but I try to do as many as I can to stack. I think most of these images were probably in the, as you've seen so far, we're in the 2 or 3 minute exposure range.
Okay. All right, Bernie, let's do Saturn.
All right. Let me share the screen. Okay, what you should be seeing, kind of in the lower left or center left of the video screen right now is the planet Saturn. And if I zoom in on it, oh, by the way, this is full screen. This is the entire area that the camera is looking at. So I have to zoom in on quite a small object. As some of you have no doubt know, Saturn is about 1 billion miles away. So even though it's a fairly large planet, it's very small on an image scale. So there, as you can clearly see, or almost clearly see, is the planet Saturn. Saturn's rings are quite visible tonight. Whoops, you can see it fading out a little bit. That's a little bit of cloud cover that's been kind of wisping in and out on me this evening. And looks like it might be taking over, at least for right now.
You can still see a little bit of it coming through.
Yeah, it's drifting out on me. Looks like it's getting worse.
Yeah, we may have to come back to Saturn.
Might have to come back to Saturn. I'll leave the scope tracking Saturn for now and see what happens. Here's what Saturn would typically look like on a really clear night visually. When I say visually, I mean with a good eyepiece, a good scope on a really clear night. You can see obviously the rings. You can see this division between the A and B ring. This is called the Cassini Division.
Bernie, we're not seeing that on the screen.
Oh.
Do you want to reshare?
Okay, let
Just,
me.
You can either stop it or you can just do a
All right,
reshare.
Let me re-screen share. Where'd it go? Here, let's try this one. How's that?
There, now we got it.
So again, on a really good night, you might be able to see Saturn that clearly. Maybe not that large. It's going to be probably smaller than that, but this gives you a representative view a very clear night with a good scope. I've seen Saturn that well years ago, and I know it can be done. This little gap here between what's called the A and the B ring is called the Cassini Division, and it can be seen here and over here. The Cassini Division is a test of how well the seeing is. If you can see that gap, that Cassini Division, that means that you've got a very good clear night. If it's not there, then you've got a lot of atmospheric distortion. Your seeing's not as good. On the surface of the planet, you can also make out cloud bands, much like you can on Jupiter. Saturn, like Jupiter, is a big gas giant. It spins and it has equatorial cloud bands. They're not as obvious as the ones around Saturn, and they aren't as large as the ones around Saturn, but they are visible. Some other things that you might notice here is you see this little dark gap here, and you can kind of see it over here, just a hair, but mostly on this side. That's the shadow of Saturn, the planet, being cast on the rings itself. So this is the back side of the rings, and the sun is this way, shining in this direction, hitting the planet, and the planet is casting a shadow, just like all planets, and the moon and the Earth is casting a shadow back onto the ring plane. So that's what that band is there. That's the actual shadow of the planet on the rings itself. You can also just make out a little bit of curvature on the bottom, where the bottom of the planet is visible. On the pole cap of the planet, although it can't be seen in this picture, and I don't know that anybody has an image from Earth showing that, but the Cassini probe, the Cassini satellite that was sent to Saturn and took lots of images of Saturn, both of the rings and the planet and the poles, captured a very interesting phenomena on the pole. The pole of Saturn is hexagonal shaped. It isn't circular. The cloud band up on the top actually has a hexagonal shape to it. And I think that hexagonal shape is somewhat of a mystery yet as to why it has formed in that way. Just an interesting thing that if you haven't seen the pole cap picture of Saturn, look on the internet, do a search, and you'll see that that image showing the hexagonal shape on the pole. I'm going to go back to.
Yeah, while you're going back, Bernie, I'll just add the Cassini mission that visited Saturn is probably the most successful unmanned mission we've ever sent as far as the data it gave us. Just tremendously fantastic imagery and science on Saturn. All those images are available. If you go on the internet and search for, if you put NASA Cassini, you'll get to the website, and there's a library of all the images, and you'll see just breathtaking images that it took of both Saturn and its moons during its mission.
Yeah, especially if you compare those images to some that Voyager took back in the
Huge. Well,
late 70s.
And especially what Cassini did as its final act, it did what was called the death dive. It got itself aligned along the poles of Saturn and dove through the gap between the planet and the rings. And it actually did this several times. It survived its first several passes through there until it finally just ran out of fuel and control authority and crashed into the atmosphere of Saturn. But it got some good imagery then too.
I stepped up my exposure time, and I was able to pull it in a little bit. It's evidently blasting its way through the clouds a little bit now. So you can start to make it out again, not as clearly as previously. And it's still kind of fading in and out. But one thing I wanted to try to do here was to overexpose it and see if we can get some of the moons to show up. So let me give that a try. I'm doing a long exposure to see if I can get some of the moons to pop out. Okay, there we go. So what have we got here? You can see Saturn, the oval shape there. And this, I believe, is Titan, Saturn's largest moon. Let me see if I can verify that. I've got a set of images here, so I'm going to see if I can. Yeah, that's Titan. This spot right there is Titan. This one is a closer moon. This is the moon Rhea. Then to the left, this one, which is a little fainter, is Tethys. This is Tethys. And the one right below my mouse is Dione, or Dione. And it's fading out again. So you got a chance to see some of the moons there before it, before the clouds took over on me. Yeah, the clouds are definitely moving in now. So
Yeah,
I'm afraid
well, I'm
that's
glad we're
probably going to be the end of it for now, at least. I could try a little later and see if it gets any better, but
No, that's good, Bernie. I'm glad we were able to get in some live views of both Jupiter and Saturn. So why don't we go back to Rick, and Rick, let's do your other two, and then we'll see if Jim O'Connor's ready to, if he's able, we'll let him talk a few of his, and then Bernie will go back and catch some of your images.
Okay.
yeah, I'll see if I can pull something else out of the sky here before the cloud cover comes back again.
Okay.
Okay, so now for something completely different. This spectacular object is the Great Andromeda Galaxy. This is the nearest spiral galaxy to our own. It is very large in our sky. This is an uncropped image from my camera. If I had my camera and telescope focused on the moon would fit inside this entire frame quite easily. This object is much larger than our full moon in the sky. It's also the most distant object you can see with your naked eye. And yes, you can see this with your naked eye if you know where to look. So if you have an app on your phone, you could search for the Andromeda Galaxy and it would show you where it is in the constellations. And if you're, outside of the Tucson city limits under, dark skies with no moon out, you'll see a smudge, and you could be able to see this. It's very visible in binoculars. You won't see this much detail in binoculars, but you'll definitely see this center core, this bright part of the galaxy, and a little bit of this elongatedness from this bright region. So what you're able to see in this picture, you'll see these dark lanes are going around it. These are dust lanes that are between us and the bright center core of the galaxy. You'll also notice up here to the left, there's another really bright spot. That is a companion galaxy to Andromeda. Now, our galaxy also has companion galaxies. They're called the Large and Small Magellanic Clouds. Well, you may wonder why you've never seen these. Well, that's because they're not visible in the Northern Hemisphere. If you were to go down to Australia, Australians are very familiar with seeing the Large and Small Magellanic Clouds up in their night skies. We just unfortunately can't see them here in the Northern Hemisphere. So this is the Andromeda Galaxy. It is absolutely enormous. It's 2.5 million light years away from us, and it's about 131,000 light years across. So it's a bit larger than our own galaxy also, and it's moving towards us, but it won't get here for a very, very long time. Another interesting thing about Andromeda, it's only been known as a galaxy very recently. For most of man's existence, this was thought to be a nebula like the other objects I've shown you. It wasn't until 1925 that Edwin Hubble, yes, the same Hubble that the Hubble telescope is named after, had the resolving power in a telescope and camera equipment to be able to resolve this. And he was actually able to measure a variable star within the galaxy. And the measuring of that variable star confirmed to him that this was an object outside of our own galaxy. And when he was able to see the structure, he was then able to confirm that it was another galaxy like our own. And that didn't happen until 1925. And that was really the first discovery that there was a galaxy outside of our own, was that discovery in 1925. Anybody else want to add anything about Andromeda?
No, that is again a gorgeous picture. I'm just kind of moving my cursor along the bus lane.
I'm looking forward this year to getting some more photographic time in Andromeda, because Andromeda has nebulas inside of it, just like our own galaxy does. And with the right kind of filters and things, you can actually pick out little patches of pink in the galaxy, and those are the nebulas inside of it. So I'm looking forward to trying that later this year.
Yeah, and as Rick mentioned, Andromeda is slowly drifting towards us. So if you were to live for another 4 billion years, you would see Andromeda getting larger and larger in the night sky until the two galaxies actually merge. Andromeda is one of the other large galaxy in our local group. So Milky Way and Andromeda are the two big kids on the block. All right, very cool, Rick. Let's do your last one. Let's go ahead and talk about the North American Nebula.
So I think right off you can see how this nebula gets its name. It's turned sideways to the left, but if you look on the right-hand side, that arm sticking out looks like Mexico, and this gap in between looks like the Gulf of Mexico. So this reminded people when they first saw it of the North American continent. So that is how it gets its name. This is a very, very, very large structure. They actually don't know exactly how far away it is. It's hard. This is one of the objects it's a little hard to measure its distance. It was again discovered by William Herschel in 1786. It's somewhere around 1,800 to 2,600 light years away, which is relatively close to us in galactic terms. Because of that, they don't know its size exactly, but it's about 90 to 100 light years across. Now, some of the other things I've shown you were in the 100 light years across, but they weren't nearly this big. So that's how you can tell, A, this is closer to us. And that's why it's so big in our sky. Again, it's much larger than a full moon in our sky. And again, this is a big cloud of gas. It's a star-forming region of gas, just a big region of hydrogen gas. Again, I was able to image this using narrowband filters. Some of the, it's fun to look around this image and pick out some of the structures you can see. Some of the most beautiful ones to me are down in the peninsula area, down towards the lower right-hand part of the screen. There's a light and dark cloud structure you can see there that just has some beautiful structure to it. And you can see some more of that as you move up the arm. And then the inside part of the Gulf, you can see this wispiness that just looks like a windblown cloud. Just some spectacular structure in this. Anybody want to add anything on the North American?
Very good, Rick. Now that's another gorgeous picture. It's an emission nebula, so it's being lit up by lots of stars coming to life in there, and it's just huge. Yeah, it's great. All right. Let's see, Bernie, do you have anything else on the telescope, or should we go and see if Jim wants to talk some objects?
Okay, update on the sky. The clouds have moved back in again. Unfortunately, I've got total cloud cover. In fact, I've got some lightning getting closer off to the south. So I went ahead and closed up the dome before it started to rain on it and get the telescope all wet. So I think doing any live from here is probably, that was probably the end of it for the evening.
Yeah, probably.
I've got some objects I can go through, but certainly Jim wants to take over and do one. That'd be great.
Well, before we leave your view, can you move your camera so that we can see the telescope? We've had a request that if you can show a picture of your telescope up there, so maybe you can, you have to talk to get your picture to come back live, but if you want to show that, that would be great.
Sure. Let's see, I don't know if it's going full screen yet. Doesn't appear to be. Not sure why that's not going full screen.
We can see it fine. It's fairly well filling up the screen, so I think maybe go up a little bit higher.
Okay, just kind of make it out. This is the, let's see, here's the Astrophysics Mount. This is the hydraulic lift mechanism that I can use to lower and raise it. This is a muon reflector, has a high F ratio. I don't remember exactly what it is. I think it's up around 15 or so. This is the 8-inch TMB. And then outside of the view, and up above, a little bit higher yet, there's a 150 millimeter Lunt solar scope. So that's all in a fairly large stack here on the Astrophysics Mount.
All right,
And
very nice.
Located, I'm located in the Norwood Young America area of Minnesota. It's about 45 miles southwest of Minneapolis. And the skies here are I'd say around portal 3, maybe portal 4, 3.5, somewhere in that range.
All right, very good. We're going to try, see if we can get Jim to come up voice here. I don't know that I can unmute him. Doesn't look like I can, Jim. So let's see if you can unmute yourself. Looks like you're unmuted.
Yep, I think I pushed the right buttons. Have you got me there?
I do, yes. We've got you loud and clear. So let me get yours up. We'll start off with M13.
The object we're going to look at is named Messier object number 13. And the reason I like to look at globular clusters is because they're like me, ready for a retirement home. These are very old objects, and they've caused a little bit of curiosity among astronomers as to how can the Milky Way be, on the average, without these objects that are circling it, about 7.5 billion years old, yet about 150 to 160 of these objects are circling the outer halo of the Milky Way, and they're anywhere from about 10.5 to over 12 billion years old. So the question always was, where did they come from? So it's fun to study these, and we've gotten quite a bit of answers in the last few years. Globular clusters themselves are tight balls of anywhere from 10,000 to over 1 million very old stars in orbits around the Milky Way's core. The oldest of the Milky Way stars, about 7.5 billion years old, but these things have stars that are 12 billion years old or sometimes a little bit older. The stars that are left at this time are about the sun's age. They're not much, they're older than the sun, but they're the sun's type. They're the sun's mass. The older ones have already gone to supernovas. And in M13, which is called the Hercules Cluster, or the Great Cluster in Hercules, that one has got an interesting object in the center of it, an intermediate mass black hole. And so that solves part of the mystery of where did these objects come from. That is the thumbprint almost of a small galaxy, the core of a small galaxy. So it looks like when the Milky Way started to form, the gigantic size, relatively gigantic size of the Milky Way started to form, it started to steal the gas that was around the smaller galaxies that had formed not very long, maybe half a billion years after the Big Bang. It started taking the gas that was in those small galaxies and making it part of the Milky Way itself, sort of like a stellar cannibal. Some of the galaxies of the globular clusters, though, don't have these intermediate mass black holes, at least that we've discovered yet. And in addition, some of these, even though they don't have the supermass, not a supermass, but an intermediate mass black hole in the center, all of the stars are approximately the same age, as though the object was formed out of a gigantic gas cloud not very long after the Big Bang. And then there's a third type. You take a look at these objects, and they've got two different ages within them. So it looks more like it was smaller clusters that attracted each other and are now being held together by their own gravity. So they're fascinating to study, to look at. Messier 13, which is this object here, the Great Globular Cluster, is in the constellation Hercules. It holds several 100,000 stars and is viewed in the constellation Hercules, which has got its name in Roman culture from the legend of a hero in the Greek culture called Hercules. So you can mix and match sometimes the stories about either Hercules or Heracles. But the one we use as a constellation is Hercules. And this object is sitting in one edge of that constellation. This one itself was discovered by Edmund Halley in 1714, but is cataloged by Charles Messier in his catalog of dynamic objects in 1764. There's about 145 light years in diameter and nearly 12 billion years old. M13 itself is close to 25,000 light years from Earth. The constellation itself, representing both the Roman hero Hercules and the Greek hero Heracles, was one of the 48 constellations that was originally listed by the astronomer Ptolemy XIII in 154 AD. Later, in the 1920s, when the International Astronomical Union was trying to bring order out of chaos, they sort of recatalogued things and came up with a consistent way of naming things. But Hercules hung in there, and it's now one of the 88 modern constellations.
All right. I'll
Yeah,
just go right to them.
That was
Go ahead,
great,
Jim.
Jim. Well, one thing I wanted to add for everybody about this star cluster is it is one of the objects that is visible to the naked eye under dark skies up in Hercules, if you know where to look. And with binoculars, you can clearly see this will be a smudge, and it's not a star. So again, get out there with your binoculars. You can actually see this thing.
Yeah, and it looks really good. And
High altitude or with a clear sky, or you use a camera and choose your imaging, your integration time very, very carefully so you don't swamp the view a little bit. There's actually a propeller in there you can see, a shape of a propeller. And some people have found the dark shadow of a propeller in there. So that gets to be a contest when we're up at the Grand Canyon Star Party at times, whether we can spot the propellers in the Hercules cluster.
okay, now we got M22 up there.
Well, this is a very interesting cluster because this is called Messier 22. And we haven't mentioned it much, but Charles Messier, from the mid-1700s until the early 1800s, had a job that was called draftsman and chronicler of dynamic events for the French Navy. His uncle had gotten him the job because he was kind of being lazy around the home farm because they didn't need him. They had enough staff. So he gets him a job to be a chronicler of dynamic events. For the French Navy, that meant comets. So Charles Messier's job for his astronomical career was to discover objects that were comets because the French Navy was somewhat superstitious. They thought that the comets were trying to tell them something. So he made up this catalog so that we wouldn't get confused and we wouldn't think these were comets about to form. So he put many of the most beautiful objects, primarily in the Northern Hemisphere, in this catalog so we wouldn't confuse them. And his quote in his very first book, the first 40 that he put in his catalog, was that he was noting them so that scientists would not think of them worthy of study. And these are some of the most beautiful objects in the universe, but that's so that you don't waste your time looking at it and you spend your time looking for comets. This object itself is in the constellation Sagittarius. We don't see the centaur. Sagittarius is a centaur, half man, half horse, and he is pointing his bow and arrow at the Scorpion. So it's in the southern horizon, right in the southern, a little bit more elevated down here for us, down in Arizona. So he's got a bow and an arrow pointed at the Scorpion. But we see it as a teapot. And the spout of the teapot has steam that seems to be coming out of it. And that's the Milky Way. We follow that steam all the way across the sky, and we can go all the way to the constellation Cassiopeia in the north and see the summer Milky Way up there. So we don't see, unless we have a good imagination, that centaur. But the interesting thing is that Sagittarius had offspring. One of his offspring is named Centaurus. And it is a constellation in the southern hemisphere, although we do get about a fourth of it visible to us here. So it's unusual that there's only 88 objects cataloged as constellations in the sky, but 2 of them are centaurs. This object here is a fantastic cluster. Bernie has taken a good picture of it, but it's kind of overexposed. If you would underexpose it only to about 20 or 30 seconds, you can actually see a phenomenal number of red giants in there. Since this object is close to 12 billion years old, that's about the best lifespan we can expect out of normal up to maybe 6 times as big as the sun. And then they start turning into a red star as they start converting the helium they've made into carbon and oxygen. That red giant then becomes very luminous and you can actually see the red giant. But at night, your eye is looking more for black and white. So you have to be kind of careful with your camera if you want to get those red giants. This one is a lot closer. This is only about half as far away as Hercules was. It's about 10,600 light years away. It's one of the closest to the Earth. It's about a half a degree in the sky, but its actual physical diameter is about 100 light years. It is one of only 4 of the globulars we've examined that's known to contain a planetary nebula, or the end of life of an average-sized star, and the gases are glowing, mostly the hydrogen and oxygen left over from the outgassing when they were a red giant. But they're still there inside that cluster. 2 black holes, each one between 10 and 20 solar masses, were found in 2012, and it has led to the estimate that there may be as many as 100 stellar-sized solar black holes within M22. M22 itself has a mass equivalent of about 290,000 solar masses. Now that is packed into an object that's only 145 light years across. So you're talking about close to a tenth of a light year, maybe less, a little bit more, of this busy beehive of these retiring stars, these elderly stars ready to go on to the end of their existence. The age of this object as well is about 12 billion years old.
All right. Thanks, Jim. Let's go ahead and do another one with you. So the next one is the dumbbell.
The dumbbell is pretty beautiful, and it sometimes is compared to a similar object that's not very far away in the sky called the Ring Nebula. But the Ring Nebula is quite a bit smaller, and the reason is the distance. This one is only about half as far away as the Ring is. This one, this object itself is only about 1,400 light years distant. It's only 3.2 light years in diameter. But if you look at it, you can tell the outer surface is red. That was the hydrogen that was left over as it no longer was fusing enough hydrogen into helium to fight gravity. So gravity pulled the remains of that star together, and it took all the helium that was sitting in there like campfire ashes, and it took that helium and caused it to make first carbon and then oxygen with the 3 protons running around loose in there. So that made it grow into a huge object, a red giant, which is the end of life of most average-sized stars. Our sun itself, when it gets to the red giant phase, it's going to be almost as big as to stretch out to the Earth's orbit. So it gets so much bigger because of so much energy, but that drops its temperature a little, quite a bit too. So the extra benefit of that energy is it starts blowing those gases off. So it doesn't have long to live as a red giant. It's blowing, it's got so much energy, it's making its solar wind or its stellar wind take the gases out. And since hydrogen was the furthest most thing, it was still a star, that's on the outside. And inside is blue-green from the oxygen, doubly ionized oxygen. And why is the hydrogen oxidized? And why is the oxygen oxidized? It's because what's left, the carbon that got made, has turned into a white dwarf. And that white dwarf is so hot, it's turning out so much radiation that it's ionizing the gas. Otherwise, we couldn't see it. It's ionizing the gas into the beautiful color of doubly ionized oxygen and ionized hydrogen alpha. So this object is called the Dumbbell, and it's in a small constellation called Aquila the Fox, up near the head of Cygnus the Swan.
All right, thanks, Jim. That's a gorgeous picture that Bernie has there, and the Dumbbell is interesting to look in visually in a telescope because you can see it fairly well. Yeah, but it's going to look kind of black and white. It'll look gray. You won't see the colors like you do in photos. But this is a gorgeous picture. All right, let's go ahead and stay with you, Jim, and then we'll do your next two, and then we'll get back over to Bernie. So the next one for you is the Ring Nebula.
There's the Ring Nebula, or the Cheerio. Remember when I said that really what we're looking at is the end of life of a average size. By average, I mean from the solar mass up to about 8 times the solar mass. If you get bigger than 8 times the solar mass, you don't get to go through this passive end of life. You go through a supernova, very violent end of life, where you get scattered across the nearby universe. In the case of a planetary nebula like this, it's much more benign, sort of like sneezing its way out of existence. But if you look in the center of that ring, you can see a white dot. That white dot is the white dwarf that is making it glow. There's actually, if you get good resolution on your picture, there are 4 white dwarfs in the image of the ring. There are 2 in the center of the sort of darker area, and there are 2 in the actual color area. There are 2 in there. That is, if you have some good luck, you can pick those out too. It looks like it's a circle or a torus, but in effect, it's more of a sphere. And the sides of it, you're looking through more of the gas, so it makes it look like a circle. But a lot of people, when they see this, I've had kids up at the Grand Canyon, the first thing they say is it looks like a Cheerio, or they say other kind of profound things about this object. But that's the end of life of a star. They used to be about the size of the sun, and it went through its destruction or its outgassing about 10,000 years ago. It's expanding at about 17,000 kilometers an hour, but we haven't seen it grow much in the time we've been studying it since around Messier's time. The constellation it's in is in Lyra. That's the third. It's the brightest star of the 3 stars of the summer triangle in the Milky Way, and Vega is the bright star at the top of a very small constellation. It looks like a small harp. That's Lyra, the Lyre. And this is in the bottom, between the bottom 2 stars in that. And it's pretty easy to see. You can actually find it with a telescope without any guiding. Just look between the 2 stars and it pops right out at you. Lyra was, by legend, was a harp that was owned by the character Orpheus. Now, Orpheus's mother, and we used to call theaters Orpheums after Orpheus because he was an entertainer and he entertained with his harp. And his mother was called Calliope, which we now call circus organs. His father was Apollo. But through some tragedies in his life and some bad things that happened I won't go into, he got very frustrated and he threw his harp into the Nile River. Well, Apollo asked Zeus if they could do something to memorialize his son. So Zeus put Orpheus's harp in the sky as the lyre to remind us to try to bring joy to others.
All right, thanks, Jim. One of the questions we had on chat was how long it stays in this kind of a shape. Now, this star went through its death throes 6,000 to 8,000 years ago. So it's taken 8,000 years for it to do that. And it'll slowly expand out and get more and more diffuse and dimmer as it goes. But I don't know if you want to comment anything on that, Jim, as far as the shape.
It depends on that solar mass state, solar mass size, how much carbon is left over. The more carbon that's left over into this tight ball at the center, sort of like a space diamond. So if you get your space cruiser out, you can go get it, but it's going to be about 500,000 degrees, so you better have a long tow rope if you want to bring that thing back. But it depends on the size. The size means the amount of energy it's going to be giving out as it cools down. So how long it's going to last, every one is different. As it gets older, it gets farther apart, because as I said, this thing's expanding at 17,000 kilometers an hour, but that the white dwarf carbon star, not carbon star, but the white dwarf that's made of carbon, that heat is going to be diminishing, and eventually it'll just disappear. But every one of these nebulas, planetary nebulas, is unique.
All right, well, thanks, Jim. We're going to switch back over to Bernie now and let him do a couple, and then we'll show the video with you talking about some star lore and whatnot. Then we'll call it a night. So, Bernie, I'm going to stop the share if you want to take it over.
Oh, and Jim, they didn't give me mute instructions. They just said do start.
Whoops, I muted him.
Sorry. Did I talk over Jim? Sorry about that, Jim. Gave me a chance to put the scope to bed for the evening. Just got a couple more things to do, and I can button it up. So while that's taking place, I've got a couple of old favorites that I'd like to show you. Ones that I always enjoy showing to the public, and one that I definitely would have been showing had it been visible tonight instead of cloud cover, and that is the Trifid or the Trifid Nebula. This is also known as M8. I'm sorry, M20. I'll get that right yet. Or the 20th object on the Messier catalog. The Trifid Nebula is one that was actually discovered by Messier quite some time ago. And back in 1764, to be exact. It was one of his earlier objects. Most of his objects were in the 1770s, 1780s. But I think one of the reasons why this was one of the earlier objects for him to find was that he was concentrating on Sagittarius. And so many bright objects are in Sagittarius that I could easily see how he spent a good year or more just in Sagittarius alone. So this is located in Sagittarius, and it's known as the Trifid or Trifid Nebula because of the way that the right or the left-hand lobe is kind of divided into 3 sections, or tri. So that's where the name Trifid came from. I like to show this particular object because it's an excellent example of the 3 main types of nebulosity. Those being reflection nebula, emission nebula, and dark nebula. So let's talk about those for a while. This is a big, what's called H2 region, or hydrogen-rich region in Sagittarius. It's about 4,000 light years from here. And this particular hydrogen gas cloud is being illuminated in a couple of different ways. On the right-hand side, the blue is from reflection. Around and in front of this area of the cloud are some very hot, probably either B or O type stars that are rich in not only visible light, but in ultraviolet as well. And that light is very intense, and it's shining off of that cloud and reflecting back at us again. So that's what causes the bluish coloration there, is the reflection of hot O or blue B-type stars. On the left-hand side, the reddish area is due to ionization. So this is the ionizing gas, or gas being ionized by very hot ultraviolet stars that are dumping huge amounts of ultraviolet into that hydrogen gas, causing it to ionize, and then the ionized gas re-emits light in the red spectrum of hot hydrogen, which is at approximately 650 microns in the red spectrum. So this is called Ionization Nebula. The dark bands are the dark nebula. And actually what those are foreground clouds, wisps of clouds that are in the foreground in front of the ionized area, and they're actually absorbing or blocking the ionized light from reaching us. So that's what the dark nebula part of it is. So that's the Trifid or Tripod Nebula. This is a magnitude 6 object, so it can be fairly easily seen with a telescope of a moderate size, I would say, and something in the 3 or 4 inch range. Especially if you have a go-to mount on it, you should be able to find M20, the Trifid Nebula, and take a look at it for yourself. When you look for it, you will probably see only this part of it, the bright area that's it is red here in my image. You won't see the bluish part. That's way too dim to visually see without a very, very large telescope or a camera. So that's give you a feel for the Trifid Nebula. The other image that I'd like to show you tonight is another favorite of mine, because I have a pet cat, and this is called the Cat's Paw Nebula. Now, those of you who have a cat probably realize that the number of paw marks aren't quite correct, but nonetheless, it's a nice name for it. The Cat's Paw Nebula is in the constellation Scorpius, which is right next to M20 in Sagittarius. It was discovered in 1837 by John Herschel. And he discovered this from South Africa when he was down in that area with his telescope. And the reason it was discovered in 1837 is because it was not visible by Messier from his location in the Paris area. It was too far south and below his horizon. This particular nebula is actually down in the very tail of Scorpius. So if you go out and take a look for Scorpius, those of you who know what Scorpius looks like, it looks like a big scorpion in the sky. It even has a big sweeping tail like a scorpion does. And this is down, way down by the bottom of the tail. So you can understand why it would be hard to see for someone in Paris. It's also very hard for me to spot it here in Minnesota. It's almost impossible to spot. But down in the Tucson area and Arizona in general, this is one that can be seen quite easily. And in fact, I took this image about 2 years ago when I was at the Grand Canyon Star Party. And I've kept it for these years because it meant a lot for me to finally image it. It's about 5,500 light years away, and it's about 40 light years wide. So it would take quite a while to traverse from one side of it to the other. It's also a hydrogen, or what we call an H2 emission nebula, like most nebulas are. Not all of them, but most of them are. And because hydrogen is the predominant gas in the universe, and it's being illuminated by many, many, many hot stars that are within the star cluster that's associated with it. This is all kind of one big open star cluster here that is associated with it. In fact, it's a star-forming region. So new stars are probably being born in this star cluster. So just to give you a little feel for a couple of my favorites, the Trifid and the Cat's Paw Nebula.
Great, thanks, Bernie. All right, so we're going to wrap up with the video we talked about earlier that Jim O'Connor talking a little bit of star lore at from the Grand Canyon. So it's a couple months old, but it's still pretty cool to listen to what he has to say about the lore and whatnot. Yeah.
Yeah, I just wanted to jump in and answer one question. I saw a question on one or two questions on Facebook. A natural question that pops up when we do a presentation like this is people are asking, what type of telescope, could I get that I could see things like this? And I just want to tell everybody that's a hard question for us to answer. There is no right or wrong, one single answer. So my recommendation is that a good way to learn and find out about these things is come to some of our association's meetings where you can learn some more and reach out to some of our members, and then we can help educate and help you learn about how to make that kind of a decision. And I don't know if you want to add anything to that, Jim.
And if you're not in the local Tucson area, if your town has an astronomy club, that's a good place to check it out. Because like Rick said, there's lots of different telescopes and it can become very confusing. We're lucky here in Tucson that not only do we have the association, but we also have two great astronomy stores to help people decide. But if you're not in the local area, then your best bet's to see if you can seek out a local club or somebody that's not too far away.
I'd also like to add that just to give you a feel for the last two images that I showed you, I took them with this setup, which is a Celestron 8-inch telescope on a AVX GO2 mount and with a camera in the back. So just to give you an idea, nothing terribly special. This is an 8-inch Celestron. So if you went to the Celestron website, looked up their 8-inch, probably get an idea on how much those cost new, and they are available used on the market as well.
All right. Very good. Well, let's move on so we can get it wrapped up. So I'm going to go ahead and start the video. And before I do that, I'll just remind everybody that our next virtual star party will be October 29th from 7 to 9 p.m. Tucson time. So if you want to put that on the calendars, or the easiest way is if you go to our Facebook page where you're watching this, you can follow the event there. There should be an event on there and you can follow it, and that way you'll get reminders and any updates. Hopefully we'll have better weather. We're going to actually do that one jointly between us and the San Diego Club, so that should be fun. All right, what I'm going to do now is I am going to share the video from Jim's talk, and we'll go through that for, it's about 15 minutes long.
Hi, I'm Jim O'Connor from the Tucson Amateur Astronomy Association. Welcome to the 2021 Grand Canyon Virtual Star Party. Let's take a journey around the night sky. Since this presentation was recorded earlier, if you have questions or comments, please enter them in the chat window and we'll try to reply with an answer during this presentation. Right now, you see how the sky would look at the Grand Canyon National Park Visitor Center on the night of June 12, 2021 at 9 p.m., the sun having set an hour earlier. As we look to the north, the sky appears without guideposts to help us explore. We'll change that shortly and explore the markers we can use to guide our journey through our night sky. When the Cherokee look up at the sky, they see stars as spirits of people who have left us and spirits yet to be born. So we spend only a small part of our existence here on Earth, and we should make the best of our stay. We'll now explore 3 of our culture's sets of markers: the northern sky, the Milky Way, and the ecliptic. In 1929, to bring order to scientific astronomy, the International Astronomical Union decreed that stars would have their original Arabic names, planets would have their Roman names, and constellations would have their Greek or Latin names. Also, there would be 88 formal scientific constellations, and they would be used to divide up the night sky into manageable regions. These characteristics will help guide our exploration. We'll explore by going from the known to the unknown, starting with our first set of markers in the northern sky. We'll begin with a familiar marker, Ursa Major, the Great Bear. The constellation Ursa Major has a prominent asterism or grouping of stars we call the Big Dipper. While the Big Dipper appears as a scoop or a ladle to Westerners, to others it is called the plow or the ox cart, or even in Hindu lore, the elephant of creation. The 2 stars at the front of the ladle of the Big Dipper often are called the pointer stars and can be used to find Polaris by following them straight to Polaris. The North Star, it seems fixed while the sky rotates around it. Polaris is also the tail star of the Little Dipper, or the constellation Ursa Minor, or the Little Bear. You'll have to use some imagination to notice the Little Bear, as we only see the Little Dipper, and it's usually only the end pair of bright stars. Legend says the bears were terrorizing villages and were thrown into the sky by their tails. In a dark location, visible in Ursa Major are the highlighted feet, which are called deer tracks by some Native American cultures. Opposite the Great Bear is Cassiopeia, appearing as a big W or M, representing the vain Queen of Ethiopia. Jealous of her daughter Andromeda's beauty, because of her vanity and other evil acts, she's been chained by Zeus to a chair facing away from Olympus and forced to spend half of each day upside down. Next to Cassiopeia is her husband, Cepheus, the king of Ethiopia. In the Chinese culture, this grouping of stars is called the House of the Seven Kings. In our view from Earth, Polaris appears stationary as the center of rotation of the night sky. Nature isn't truly this way. The Earth's axis, like a child spinning top, only spins on its axis so the sky appears to rotate daily. But not only that, it seems to be moving in a great circle. So not only does the Earth spin on its axis, the axis makes a great circle in the sky. This circle of rotation center change is a 26,000-year cycle. Migration of the rotation axis star can be found by using the constellation Draco, the dragon, and the construction of the Great Pyramids almost 7,000 years ago. To have an afterlife in Egyptian cultures, a burial site needed two exits. One is to the pole star, a place of immortality where a star did not appear to move or rise or set. Permission to have an afterlife is also needed, and that required a second exit to their god of the afterlife, Osiris, Orion for us, in the opposite direction. The exits at the pyramids point where Thuban and Orion were about 7,000 years ago are no longer the position of pointing. Thuban and Osiris are no longer in the correct exit alignments. So many Egyptian spirits are wandering the sky, lost from their burial sites for about 19,000 more years until Thuban and Osiris are back in place. Let's look for two path markers for navigation. We'll slide the view to show them. If we poke a hole in the bottom of the Big Dipper, we find Leo the lion getting his head wet. Another path to follow is the arc of the Dipper's handle, called the arc to Arcturus. The brightest star in the constellation Boot is the herdsman, who keeps the bears in the sky with the aid of his herding dogs, the constellation Canis Venatici. From Arcturus, we can speed straight on to Spica. Straight on to Spica, and that gives us the brightest star in the constellation Virgo, the Greek goddess of fertility. Our next set of markers is Via Galacticos, Greek for Milky Way, leading to the name galaxy for all such massive assemblies of stars. The Maya considered the Milky Way to be the root of the tree of life. We are looking into our home galaxy, a flat disk about 100,000 light years across, composed of flat arms. From above, it would look like a rotary lawn sprinkler. Our solar system is about a third of the way in towards the core in the Orion spur. In early June, the summer Milky Way rises along the eastern horizon, stretching from Cassiopeia in the north through the Sagittarius Scorpius region in the south. Very rich in the stars of our Orion spur and the nearby Scutum Centaurus arm, with the arms separated by a dusty lane called the Great Rift. The Seminole see these arms as, and the dust band between them, as the arms of the Creator protecting his creation. Other cultures see the Milky Way as campfires of clan elders who have passed on and are looking over their former tribal members. The central feature of the summer Milky Way is the summer triangle. In the constellation, in three constellations that are so bright, the stars are visible from fairly bright city skies. The first star is Deneb, or tail. In the constellation Cygnus the Swan, also known as the Northern Cross. First Nations peoples in southwestern Canada call this constellation Niska the Goose, which announces the arrival of the migratory birds for trapping when it arises in the spring. The next star is Vega in the constellation Lyra, the lyre or harp. This is an instrument of Orpheus that was placed in the sky by Zeus as a reminder for us to bring joy to each other. In Eastern Mediterranean cultures, they saw this constellation as the eye of God. The Maya thought that their original home was in Lyra and that the ships on white wings would someday come to bring them home. The third star of the triangle is Aquila the Eagle, completing the summer triangle of stars Deneb, Vega, and Altair, which actually stays visible until January, although rising 4 minutes earlier each night. Even under moderately bright city lights, squinting your eyes will bring out these tremendous 3 markers that highlight the main body of the Milky Way. So we go on from our northern Cassiopeia location down the Milky Way to the bright triangle in the path. At the southern end of the Milky Way lies Sagittarius, the Archer, and Scorpius, the Scorpion. Sagittarius will shortly be fully risen and appears to us as a teapot, with the very center of our galaxy just above the teapot spout. The tail of the Scorpion is not quite yet above the horizon at northern US latitudes, but it will be shortly. Legend says the Scorpius slayed Orion, and in Western folklore, the two are placed on opposite sides of the sky to remind us to separate our conflicts. So far, we have followed our night sky from the Big Dipper to Polaris, Leo, and Virgo, and then from Cassiopeia inward as we look all the way across our Milky Way to the summer triangle and then to the very core of our galaxy.
Our final set of markers is the ecliptic. By the scientific name,
The yearly path of our sun through the night sky as seen from the Earth. Because of the flat nature of our solar system, the ecliptic is also the Earth view of the path of all the planets. Our moon's orbit is only about 5 degrees tilted from the system disk. Thus, the ecliptic is the area where solar and lunar eclipses can be seen from Earth. If we start at the western end of the ecliptic, we can see that the sun has set some time ago. It's also set along with Mercury and the constellation Taurus. So we have the sun and Mercury right below it, and the constellation Taurus is gone for this season. Moving up the ecliptic, we can see Gemini, highlighted by the twin brothers, Castor and Pollux. It's at the horizon right now, and it's home to Venus.
moving up the ecliptic, we see that stellarium view has automatically started to rotate in any event, to help us avoid astronomer's neck as we start looking towards the overhead. Cancer, the next constellation up the ecliptic, is very dim and it's hard to see, even in dark skies, but it also just happens to be the home of Mars right now, followed by the constellation we found earlier, Leo the Lion. Leo has many bright stars and is not too difficult to find. And it features the backward question mark forming the lion's head with the bright star Regulus at its base. This star is one that does not follow the guidelines of an Arabic name. Rather, Regulus was the name used by 16th century astronomer Nikolai Copernicus, who thought this star was the ruler of the stars and needed a suitable name. The name Regulus was retained in honor of astronomer and astrologer Copernicus. Moving on over the top and down towards the eastern horizon, we have Virgo with the bright star Spica that we visited earlier, translated as a kernel of wheat, fitting for the goddess of fertility. In addition to the handle of the Big Dipper's arc to Arcturus and then speed onto Spica, another indicator of Virgo's location is the so-called martini glass that extends to the upper right from Spica. Here we have Spica and the martini glass. If you can find those, you won't need to worry about arcing from Arcturus and speeding on to Spica. Finally, for this night, we're getting to the final, just recently risen constellations of the ecliptic. Next along the line is Libra, Latin for weighing scales, the scales of justice and Lady Liberty. However, there are two interesting stars in this constellation. The first one, Zubin esh-Shemali, and the second one, Zubin el-Ganubi. Those are translated as claw north and claw south. What do claws have to do with the scales of justice? Well, it turns out we're using Arabic names since 1929 for all the stars. Yet the Arabs didn't have anything in that region in their culture to be able to assign a name appropriate. Instead, they thought the scorpion went all the way from Scorpius, where it is right now, all the way up to the two claw stars. However, in 1929, when they were naming the stars in the International Astronomical Union, they declawed the scorpion so we could have a constellation Libra. Finally, for this night, Scorpius will shortly be totally above the horizon, and Sagittarius the archer, who really is drawn as a centaur drawing a bow, he looks like a teapot whose steam forms the summer Milky Way, and it's just making his appearance. Here we are looking straight into the core of our galaxy, about 30,000 light years away, centered on a 4 million solar mass black hole at the core. Saturn will be rising later tonight, about 11 p.m., Jupiter about midnight, and Neptune about 1 a.m. The elements of the ecliptic have an alternative use. Several millennia ago in the Eastern Mediterranean, the position of the sun as it moved through constellations was used for military and municipal guidance. Later, the Greeks adopted the concept and greatly expanded it, giving us the name Zodiacos Kyklos. In ancient Greek, the cycle of the sun through living objects. But in modern Greek, it merely means any circle of animals. We now call it the zodiac. We have explored the use of markers to follow the sky we live under, the North Star and items around it, the Milky Way itself, and to the galaxy core, and the ecliptic, also known as the zodiac. We're back to our starting point. We've made quite a journey from the Big Dipper and the pointer stars to Polaris onto Cassiopeia and the view inside our home galaxy, ending with the arc of constellations of living entities that our sun visits separately every month. Thank you for joining in our journey through this one evening's offerings. Remember to look up whenever you can and perhaps make up your own stories. Please enjoy the rest of tonight's presentations.
All right, that was nice. It's a good summary of what's up in the night sky and everything. So we're going to wrap things up here. We hope that you guys enjoyed the presentation tonight, and will join us again when we do the October 29th event. Hopefully, like I said, hopefully we'll have better skies, and we can do some more live views and be able to take some requests from from the participants. So be sure to follow the event on Facebook. And if you're in the Tucson area, come join us for any of our public events. We've got several coming up. You can track the events on Facebook, or you can go to our website listed here, just TucsonAstronomy.org. And you can, if you go to the calendar, you'll see events coming up. But we are going to, even though we start priming up on more in-person events, we want to keep the quarterly virtual events going so we can reach out. We've had, we had people from all over the US, so that's great. We appreciate you guys all tuning in. Sometimes it's a little late in the East Coast, but that's the way it goes. So with that, we're going to sign off on Facebook. And if anybody, Bernie or Rick, if you guys want to say any quick farewell before we call it quits, go ahead.
Well, I just wanted to mention that if any of the viewers are in the Minneapolis or Minnesota area, you can also come out to our Minnesota Astronomical Society Observatory public nights, which are held every other weekend. And you can go to the MAS website to look on the calendar and see when those are. I believe there's one tomorrow night, a little short notice, but should be every other weekend after that. So just a little plug for the MAS, as long as I'm using their observatory here.
Absolutely. Rick?
Yeah, I just wanted to thank everybody for joining us tonight. Hope everyone enjoyed it, and look forward to seeing everyone online here again in October.
All right, sounds good. Thanks, everybody. Have a good night.
All right.